This is section 13.1, sample space and probability. So we have a spinner here and it has 3 different colors. So write the event blue appears exactly once when we spin the given spinner 3 times as a set of outcome. Okay, so blue appears exactly once, not twice, not 3 times, exactly once in blue. So let's list all the possible combinations. So if blue comes first, we have 3 spins. We could spin blue, red, and then yellow. Remember, blue can only occur once. So we could have blue, yellow, and red. We could have blue, yellow, and yellow. And we can have blue, red, and red. So those are all the possible outcomes where blue occurs exactly once or blue comes first. And then what I do from here is I just move the position. So red, I'm going to move blue to the middle of each of these. And then I also move it to the end. So red, yellow, blue, yellow, red, blue, yellow, yellow, blue, and then red, red, blue. So those are all the possible outcomes. Now in your homework, it's just going to be multiple choice. All right, we were flipping 3 coins. Outcomes in the sample space are represented by strings of H's and T's. That's heads and tails. How many elements are in the sample space? Okay. So we have 3 coins, and each coin has 2 possible outcomes. So if you multiply those together, the total number of outcomes you have are 8. That goes back to chapter 12. Express the event there are more heads than tails as a set. So we're flipping the coin 3 times, or flipping a coin 3 or 3 coins, either one's the same thing. More heads than tails. So if we're flipping 3 coins, it has to be 2 or 3 heads, right? Well, it's 3 coins. The only way to get 3 heads is like this. There's no tails at all. So now we need to run through all the possible combinations where there are 2 heads. So we can have both of them first. We could have them split. And then we can have them at the end. So there's 4 ways to have more heads than tails. Okay. So this is what they're looking for, this part right here. What is the probability that there are more heads than tails? So that's more heads over your total. So that's the total possible outcomes that you can have. There's 8 total possible outcomes. 4 of those are more heads than tails. You do have to reduce that. That's 1/2. So on your calculator, you can put it as a fraction, or you can do 4 divided by 8. Your calculator will reduce and simplify fractions. For instance, if you had 9, let me do it as a fraction. It makes you feel better. Control. So say we have 9 over 6. Your calculator will reduce that. So if you're not sure if the fraction reduces, just put it in your calculator real quick and see if it does. If it doesn't, it'll just pop out the same number. If you don't reduce your fractions, it will mark you wrong. You need to reduce your fractions. I'm not going to give you credit back on a test because you didn't reduce your fractions. So what is the probability there are equal number of heads and tails? That means the same number of heads and the same number of tails. Okay. For us, we have 3 coins. There's no way to have equal number of heads and tails. So the probability is 0. Now, if you get one where they have 4 coins, that is possible. So you would have to find all the possible combinations. So let's look at this. Let's just do a little, if there's 4 coins, oops. All right, let me get myself, I'm just giving myself a little room here. So this would be, say, if you had 4 coins. Okay. So the total you could get would be 2 times 2 times 2 times 2. That's 4 and 4. That's going to be 16 total possible ways. Equal number of heads and tails. Okay. And what I do is I just shift that H, that first H, or the second one, I'm sorry. And let's look at it. So let's heads first. Let's do tails first. Tails, heads, heads, tails. I'm trying to, let's see if there's any other combinations. T, H, H and T. So that's 6. So the probability there are equal number of heads and tails for this problem would be 6 over 16, which reduced to 3 over 8. So this had a 3 over 8 possibility of equal number of heads and tails. But the problem that we had, it was 0 because there are 3 coins. How are you supposed to get equal number of heads and tails? So depending on which problem they give you, the answers may be different. But you can have 0 probability. It is possible. Probabilities run between 0 and 1. Most of the time, you don't get 0 or 1. You have some fraction or decimal. All right, in a given year, 4.9 million males and 5.1 million females were born in a certain country. If a child is selected randomly from this group, what is the probability that it is female? So in words, we need the total number of females over all children. So females is 5172566. The total is going to go on the bottom. I do recommend that you actually write these out on a sheet of paper before you put them in your calculator. So I am going to need this converted to a decimal. And let's use 2 decimal places, 0.51. So however many decimal places they ask you for. So about 51% of the children are females. And the answers on this section, some of them will be fractions. Usually it's the smaller fractions. And you'll have some that will be decimals. So make sure you read right below where you put the answer and it tells you what to round to in blue. If you see the word fraction at all, then it's going to be a fraction. A cookie is selected at random from a basket containing 24 mint cookies, 16 caramel cookies, 14 peanut butter cookies, and 6 sugar cookies. Find the probability that a mint cookie is selected. So first of all, how do we set this up in words? That would be mint over the total. All right, so there's 24 mint. Then we need the total of all the other cookies. 14 plus 6. And you're more than welcome to add all the total up by itself first and then put it under 24. Just whatever works best for you. Okay. Let's flip over to our handy dandy calculator. Oops. So, oh, look at that. That is 2/5. I do know this one they do want a decimal, so I have to convert it to decimal. 0. And this one may not tell you what to round to because they know the decimal stops, but you will not see the word fraction in there. Suppose 4 cards are drawn from a well-shuffled deck of 52 cards. What is the probability to all 4 clubs? Okay, so you can Google deck of cards image. This is the one that I like. So let's review this real quick. All right, so if you look on the right, Jack, Kings, and Queens, those are your face cards. You have 12 face cards. You have 13 diamonds, 13 clubs, 13 hearts, 13 spades. All right, it's 52 cards altogether. 26 are red, 26 are black. And then they call these ranks. So aces, there's 4 cards in each rank. So there's 4 aces, 4 twos, 4 threes, and so forth. There's no jokers in here. Anytime you're dealing with statistics or probability, this is the deck of cards that they are referring to. Suppose that 4 cards are drawn from a well-shuffled deck of 52 cards. What is the probability that all 4 cards are clubs? So the probability of 4 clubs. And we are going to multiply these. Oh, where are we at? Right here. All right, so clubs, there's 13 out of 52. But once you draw a card, you're drawing 4. So after you draw the first one, how many cards do you have left in the deck? 51. And if you pull the club on the first draw, how many clubs do you have left in that deck when you go to draw that second card? 12. All right, you pull out the second club, then how many cards do you have left total in the deck? We're not putting the cards back. It's going to be 50. So how many clubs do we have left if we've drawn 2 clubs already? 11. You can see the pattern here. Okay. Believe. Okay. I don't think this one, 30, 12. I don't believe this one was a decimal. I mean, a fraction. So let's convert it to a decimal. 0.0026. They may ask for a fraction. I don't remember right offhand on this. 11 over 4.65. So depending on which answer they ask for. All right. So the next one, suppose that 6 cards are drawn from a well-shuffled deck of cards. What is the probability that all 6 are red? Okay. 1, 2, 3, 4, 6. And we're multiplying these probabilities. Let's go back to our deck of cards. So how many are red? Half the deck is red. It's 26 of the 52 cards are red. So if you pull a red card on the first draw and you put it to the side, how many cards do you have left in the deck? you have 51. And then if you've pulled a red to start with, how many reds do you have left? 25. So again, we can see the same pattern here. Let's flip over to our calculator. And since they are being multiplied, you can just do it as one fraction. That's why I didn't separate them. Two, three, four. Decimal, let's do 0.011. And let's see what the fraction was again. 253, 22372. Let me double check that number real quick. No, 223. Oops. Okay. Depending on which answer they want, this is the fraction and this is the decimal. Some of these, if the decimal is pretty small, they may ask you to round to 4 or 5 decimal places, again, depending on how small it is. So just read those instructions. All right. So this table summarizes the marital status of men and women in thousands in the United States in 2006. If we randomly pick a male, what is the probability he is divorced? All right, I don't know why they're two different colors. I took this table out of the textbook. So if you randomly pick a male, what is the probability he is divorced? So in words, what's going to be on the bottom? It's going to be male. And on top, it's going to be divorced males. So it didn't say if we randomly selected a person, it says if we randomly selected a male. So we're not worried about the female information. All right, so we have divorced males over males. Divorced males is 10,818. And then all the males, I can't draw a straight line on this thing, is we're going to add all these up. Some of the tables give you the totals, some do not. So we flip over to our calculator. When you have a bunch of numbers like this, on any of these, just take your time putting it in. Okay, I know this one's a decimal for sure. And let's do 3 decimal places, 0.093. They may ask for a different number of decimal places. So about 9% of the males are divorced. And this is it for section 13.1.